In pre-cal for my bonus project, I am going to be talking about the dot and cross products, the similarities and differences between the two, and how they apply to the real world. First, I'm going to be talking about what the dot product actually is. The dot product is an algebraic operation that takes two equal-length sequences and returns a single number. By sequences, I mean vectors. We are basically doing multiplication while keeping in mind the vectors that are moving in the same direction. Next, I'm going to be telling you what the definition of the cross product is. The cross product is when a vector is perpendicular to two given vectors, usually u and v, while having magnitude equal to the product of the magnitudes of the two given vectors multiplied by the sine of the angle between the two given vectors, which are usually represented by u times v. Next, I'm going to be talking about the differences between the dot product and the cross product. The first difference between the dot product and the cross product is that the dot product results in a scalar quantity, while the cross product results in a vector quantity. The dot product follows commutative law, while the cross product does not follow commutative law. By commutative law, I just mean number operations of addition and multiplication. The dot product of vectors in the same direction is maximum. The cross product of vectors in the same direction is 0. The dot product of orthogonal vectors is 0. The cross product of orthogonal vectors is the maximum. The dot product does not follow the right-hand system, but the cross product does. The direction of the cross product is found using the right-hand rule. The dot product is used to find the projection of vectors, while the cross product is used to find a third vector. This third vector is always going to be orthogonal. And the last difference between the dot and cross product is that the dot product is represented by a dot, and the cross product is represented by a cross. Okay, so visually you can see how the dot product has two vectors. I labeled one u and one v, and here is the angle theta. They are trying to make this triangle shape using these two vectors. For the cross product, you have three vectors. I labeled this one A, this one B, and to get the third orthogonal vector, you find the cross product of A and B together. So this is the angle theta between vectors B and A, and to find the area of this figure, just as a reference, you would take the absolute value of the cross product. Visually, the dot product, it has two vectors. The cross product has three. This third orthogonal vector makes this whole thing 3D because it is going upwards. This is like the y-axis and this is like the x-axis. A real-world example of when you would need to use the dot product would be if you had an object at the top of a hill with an angle from the ground. Of course, you have gravity pulling it down, and you are asked how much force it would require to keep the object at the top of the hill without it sliding down. So first, you would need to find the directional vector, and then you would find the weight vector, and then you would find the force vector, all using the dot product. An example of when you would need to use the cross product in the real world would be if you were trying to tile a floor And in order to tile that floor, you would need the area of that floor. So in this situation, the outline of the floor is a parallelogram. We know the vertices and their points, so in this situation we have A, B, and C as the vertices with their individual points. And to find the area, first you would need to find the vectors using those vertice points. So you would subtract them from each other. So if I was going to A to B, if I was trying to find this vertice, I would subtract 3 minus 1, and then 4 minus 2, 5 minus 3, because they are both in those different situations. So this is the first column, this is the second column, and this is the third column. So next, you would find the cross product using the vectors found. So after you know the vector here and the vector here, you could find the cross product between the two of them. And once you have the cross product between the two of them, you take the absolute value by square rooting the equation, and then you get the area.